We're now ready for lesson 1-8, and you can see our title today is three-dimensional figures. And I've got two goals, two learning objectives for us. I want you to, at the end of this lesson, be able to identify and name three-dimensional figures. And we're going to start off this lesson in just a moment with some terminology and some ways that you can know which three-dimensional figure you're looking at. And then number two, we're going to spend some time looking at some formulas to help us calculate the surface area and volume of these three-dimensional figures. So let's just jump right in, first of all, with some terminology. The first term we want to cover is a polyhedron. Polyhedron. It's a solid with all flat surfaces that enclose a single region of space. Okay, and I've given you a diagram here, a little picture to help you with some other terms that we're going to identify here to just complete this definition. Each flat surface, or we call that a face, is a polygon. So in case you're wondering where's this arrow pointing, it's pointing at one of these. So this would be one of the faces. And as you can see, it is a polygon. All right, so that's one of the faces, and we're going to spend some time in our assignment today actually identifying all the faces of a polyhedron. All right, the line segments where the faces intersect are called edges. All right, so you can see where faces intersect each other, this face and this one over here on the side, right side that you can barely see, where they come together represents an edge. And then the point where three or more edges intersect is called a vertex. All right, let's now identify, now that we know what a polyhedron is, let's look at a couple of examples of shapes that qualify as polyhedron. One of these you can see the picture of is called a prism. So a prism is a polyhedron with two parallel congruent faces called bases. And these are connected by parallelogram faces. Okay, so this darkened blue area is one of the bases, and you can see that there's another one on the bottom. They are parallel with each other. And then the faces are parallelograms that connect the two bases. Okay, so a prism is a polyhedron, and it looks like that. Various forms, but it takes this general characteristics that we've defined. And then we have this other polyhedron called, you could probably recognize it, it's called a pyramid. It's a polyhedron that has a polygonal, okay, that's just a form of the word polygon, meaning the base has to be a polygon. It's a polygonal base and three or more triangular faces that meet at a common point. And you can see this has a rectangular base, and then you can see the triangular faces that meet together at this vertex at the top. So those are both polyhedron, prisms and pyramids. They qualify as polyhedrons. Now let's take a look at some counterexamples. These are solids. They are three-dimensional figures that we'll be looking at, but they do not qualify as polyhedron. So one of these is called a cylinder. All right, got you a picture here. It's a solid with congruent parallel circular bases connected by a curved surface. So that's one of the reasons why this cannot be a polyhedron. The main reason is because for polyhedron, they have to have all flat surfaces. And you can see obviously that this cylinder does not, and no cylinder does. So cylinders do not qualify. And then we have our next shape. It's called a cone. So it is a solid with a circular base connected by a curved surface. Okay, so you can see the base down here at the bottom, the curved surface all the way around to a single vertex. All right, also not a polyhedron. And then finally we have a sphere. Set of points in space that are the same distance from a given point. So a three-dimensional circle, as it were. So these three do not qualify as polyhedron, but the previous two, prisms and pyramids, do. Okay, just to distinguish between. Now they're all going to be talked about, and we're going to look at how to find surface area and volume for all of them, but we basically place them in two different categories with that new term. Maybe it's not new to you, maybe you've seen that in the past, but the term polyhedron is how we classify them. Okay, so let's talk about surface area and volume, and then we'll get into naming whether or not a shape is a polyhedron, and then identifying what the bases, faces, edges, and vertices are. So we would define surface area before we just jump into formulas for surface area and volume. We would define surface area as a two-dimensional measurement of the surface of a solid figure. The surface area of a polyhedron is the sum of the areas of each face. All right, and we'll get specific on formulas in just a minute. And then finally, we can define the term volume. Volume is the measure of the amount of space enclosed by a solid figure. Okay, so your assignment examples are going to look like these. I've got really two different types of problems on your homework. One of them will look like this. You're going to be given a three-dimensional figure, and you first have to decide whether it is a polyhedron. Okay, so that'll be answer part A. Well, this is a polyhedron. All flat surfaces. The faces are polygons. The base is a polygon. No curved surfaces. And now we're going to get specific and identify it. And the way we identify this is, first of all, by its base. It has a rectangular base. I mean, technically it's a square, but you just have to be in general. It is a rectangular base, and it's also a pyramid. So we would call it a rectangular pyramid. And now, if it is a polyhedron, which we've established that it is, now we're going to name the bases, faces, edges, and vertices. So there's only one base, and we could say that that's rectangle ADCR. And now we'll identify the faces. And we'll just use, these are all triangles, so we'll use the symbol for triangle. And we got a few here, so we could say AER, triangle AER. Triangle AED. Triangle CED. And triangle REC. And the base also counts as a face. So just want you to be aware of that. So ADCR. So those are all the faces. One of the faces, or could be two, depending on the shape, would also be considered bases. All right, and so now we'll do the edges, and edges are going to be line segments. So for example, we have edge AE, DE, CE, RE, AD, DC, CR, and AR. And then finally, the vertices are, try to squeeze those in down here, are points A, D, C, R, and E. All right, and so that completes, that's an example of the type of thing you'll be doing in part of your assignment for this homework. All right, let's take a look at another example. And letter B is the shape that we're supposed to go back, and we'll go back and look at our directions. Determine whether the solid is a polyhedron. This is not a polyhedron. It is not a polyhedron. Then identify the solid. It is a cylinder. All right. And then if it is a polyhedron, we're supposed to name the bases, faces, edges, and vertices. But if it's not, then all you have to do is say that it isn't, but then you do need to go ahead and specify the shape that it is. All right. Then letter C, the same thing. We're supposed to identify if this is a polyhedron, and we would say it is. And then how would we classify it? Well, the way you describe in this case, the prism, you look at the shape of the base, the two bases. And this would be called a pentagonal prism. So you'll always have some adjective in front of the actual, whether it's a prism or a pyramid, based on whatever the base shape is, whatever that the polygon of the base is. All right, and so now we're ready to identify the bases. There's two. We'll just say pentagon, or I'll just go ahead and say pentagons. Z, I'll just start down here. PWXYZ. And RQVUS. All right, and the faces are going to include those. and these other rectangular sides, we'll just say rectangles, YUVX, WXVQ, PWQR, ZSRP, and let's see, we got them all, ZSUY, then we have edges, and these will be line segments, so we have YU, XV, WQ, PR, ZS, and then we've got these going this way around the bases, so YX, XW, PW, PZ, and ZY. And then around the other end, the other base, UV, VQ, QR, RS, and SU. And then finally, we have our vertices, our vertices. That's the last thing we're supposed to do. So these are all the points. So we'll just list those out. There's a bunch. So Z, Y, X, W, P, just every point that's listed. U, V, Q, R, S. I think that's it. So we're done. A lot of stuff to include, a lot of information to provide, but that's the kind of thing that your homework will entail, some of the problems anyway. And now we're going to shift gears to surface area and volume problems. And I'm going to set your mind at ease. I'm going to give you, as part of your note packet, you will have all of the formulas that are needed for surface area and volume for these three-dimensional figures. And you're also, for this Chapter 1 test, you'll be able to use that sheet on your test. Now, eventually, when we get further into the year, we're going to actually know these formulas without having to look at the sheet. But this first time around, I'm going to let you use it. So letter Roman numeral 2A for this rectangular prism, I went ahead and you can look at the sheet, but I just went ahead and put the formulas that we're going to use, the surface area. And just so you'll know, being able to interpret these letters, capital B is the area of the base. All right. And then this lowercase l, this is on the sheet that I gave you that has all the formulas, but lowercase l stands for the slant height. And then here we are again, the area of the base. And then this is lowercase h is the height of the figure itself. Okay, so let's see if we can first come up with a surface area. We got to find the area of the base. The area of the base, since it's a square, is going to be 24 squared. So that's 576 plus 1/2 of, this is the perimeter of the base. Okay, the P stands for perimeter of the base. And so that's 24 times 4, which is 96. times the slant height. And if you notice, there's a arrow pointing at this dotted line, and that represents the slant height, and that's going to be 13. All right, so let's go to our calculator, and we'll do 96, 1/2 of 96 times 13. And then add that to 576. And we got 1200. And surface area will always be in square units, so that's centimeters squared, square centimeters. All right, and now for the volume, it's 1/3, of course, of the area of the base. We've already calculated that. That's 576. And this is the height of the shape itself, h, and so that's given as 5. If you look inside here, there's a dotted line with 5 centimeters pointing at it. And so we just go to our calculator again and do the math. 576, I'm just going to say divided by 3 times 5. And that's 955. And volume will be in cubic units. So this will be 955 cubic centimeters. So those are our two answers for Roman numeral 2, part A. I just realized, sorry about that, when I keyed in my calculator, I just noticed I did 573 instead of 576. So I need to make a little adjustment here. Let's try 576 divided by 3 times 5. Yeah, it should be 960. A little keystroke error there. Okay, all right, let's try letter B. This is a cylinder, so I went ahead and provided I just took the formulas off the sheet that I gave you. And let's do surface area first. So surface area says 2 pi times the radius, which we're given as 2, but we got to make sure we square it. So I'll just go ahead and write that in. My board's not cooperating real good. All right, and then this is 2 pi r h. All right, let's go to our calculator. And remember to use the pi button. Don't use the rounded decimal equivalent 3.14 because that is, well, that's not as exact as we'd like to use. So use the pi button on your calculator. 2 pi times 4. And then we'll add that to 2 pi, and I'll just say times 12. And it looks like we got, and rounded to the nearest tenth, 100.5 square feet. All right. And then for volume, it's pi times radius squared. I'll just go ahead and put 4 here, 2 squared times the height. So 24 pi is 75.4 rounded, and volume is going to be in cubic units, so cubic feet in this case. And that's our answer for Roman numeral 2, letter B. All right, got a couple more. Just thought I'd give you a sampling of 4 of these different shapes, 3D figures. So what we have here is a triangular prism, and here's the surface area formula. So again, this is the perimeter of the base of the shape itself. And then this is the height of the shape. Okay, so you got to be careful here. This isn't referring to the height of the base, it's referring to the height of the shape itself. So just watch that. And then this is added to 2 times the area of the base. So P is the perimeter of the base, and B is the area of the base. All right, so let's see if we can calculate the surface area. Remember the base, if you're wondering, it's in this case for a prism, it's the 2 parallel sides. So the base is going to be this triangle. All right, so we got to find the perimeter of the base. All right, so 4 plus 5 plus 3, that's 12, times the height of the shape itself. So if this is the base and then we have another base that we can't really see, remember this is a 3D shape. So the height of this shape is really right here. Remember a face, which is what we have, connects 2 bases. So this face is a height of 5 and then it would have a width of 3. So it's going to be 12 times 5 plus 2 times the area of the base. So we have to remember how to do the area of a triangle. So we're doing the area of this triangle right here. And triangle area, remember, is 1/2 base times height. So if we're looking at this triangle, remember the height is that vertical line that hits the base and forms a right angle. And so the height is going to be this edge, and the base is going to be this one. All right, so if you drop a vertical line to the base, you will create a right angle. So 1/2 base times height really doesn't matter. Either way, it's going to be 1/2 of 12, which would be 6. And so now we add those together. 60 plus 12 equals 72. And this is going to be in square meters. And then volume is going to be the area of the base. Let me erase my lines here. All right, so we just did the area of the base. That's 6 times the height of the shape itself. That's 5. And that's going to be 30 meters cubed, cubic meters. All right, and we have one more here that we will take care of. This is a cone, of course, and I gave you the surface area formula, so let's get right to it. This is pi times radius squared plus pi times radius and this is the slant height again, so that's shown as 6 inches. So now we can go to our calculator. It's going to be 9 pi plus 18 pi. And to the nearest tenth, that's 84.8 square inches. And now let's do the volume. So that's 1/3 times pi times radius squared, which is 9. And now this is the height of the shape itself. So in this particular case, they don't give us this height, and so it's easy enough to find, but if you notice, this is going to be a right angle. That will always be true. And we'll just look at this side. It's 6-inch slant height, and then radius is 3. So just think about the Pythagorean theorem. Just in case you forgot it, c² is equal to a² plus b². And the C always refers to the hypotenuse. So in this case, that's going to be 6. And we'll just call 3 a, we'll just say a squared, and we're really solving for b squared, or if you want to put h in there, that's fine. So we subtract, so 36 minus 9 is going to be b squared. Get my calculator going. So it'll be the square root of 27 is going to be b, since we're dealing in decimals. I guess I'll just go ahead and put in the square root of 27, and then we'll round in the end. That'll be a little more precise. So let's just calculate this. So pi times 9 times the square root of 27, and then we'll just divide that by 3. And that is 48.97. So we'll just go ahead and say 49.0. And this will be cubic inches. All right, I think we are done. I think we've done all the examples in your notes, and I hope that this is going to help you be prepared for the homework. Of course, there'll be a related homework help video. So if you need that, check that out. Otherwise, I will see you next time.